Your heart never actually skips a beat. What you feel isn't a missing beat. It's an early one, followed by a pause your body inserts on purpose. That split-second glitch you've felt 100 times isn't a flaw. It's one of the most precisely engineered survival reflexes your body has, refined over millions of years to keep you alive in the half-second, before danger even fully registers. Think about the last time it happened. Maybe a car swerved into your lane. Maybe someone jumped out from behind a door. Maybe you were just lying in bed, half asleep, when your mind conjured something that wasn't there. And for one strange moment, your chest did something you didn't ask it to do. Almost everyone has a name for it. A skip. A flip. But here's what's puzzling. Your heart is arguably the most protected organ in your body, monitored by its own electrical system, built to run for nearly 100 years without stopping. So why would fear throw it off? The answer is that it doesn't. What feels like a malfunction is your body executing a plan written long before humans existed. Long before language, long before fear had a word attached to it. To understand why, you have to go past the feeling and into the wiring underneath it. Starting with what's actually happening inside your chest in that moment. Here's the part almost nobody gets right. When your heart skips, it isn't skipping at all. It's doing the opposite, adding an extra beat, firing slightly early. It's the pause that follows that extra beat that you actually feel as the drop. This has a name. A premature beat, either atrial or ventricular, depending on where it originates. Normally your heart runs on a rhythm set by the sinoatrial node. It's built in pacemaker, but under a sudden jolt of stress, other cells can jump the cue and fire early. That early beat is weaker, and often doesn't fill the heart properly, so it pauses briefly to refill before the next beat lands, which comes in stronger, almost like a thump. Early beat, brief pause, forceful catch, upbeat. That's what your brain reads as a skip. Researchers at Harvard Medical School have noted premature beats are so common they occur in nearly everyone, usually without any awareness. Most people only notice them once adrenaline is already elevated. Exactly what happens when you're scared. The skip was probably always happening in small, unnoticed doses. Fear just turns up the volume. But why would fear specifically be the trigger? To answer that, you have to look at what happens a fraction of a second before you even register that you're afraid. Because by the time you consciously feel scared, your body's already been reacting for a while. Section 2. Your brain sounds the alarm before you decide to be scared. Here's something that tends to surprise people. You don't feel fear and then react. You react, and then you feel fear. The order is backwards from how it seems. Deep in your brain sits the amygdala, a small, almond-shaped cluster of neurons and one of the fastest-acting structures in the nervous system. Its job is threat detection. When your eyes or ears pick up something that might be dangerous, a bang, a shape moving too fast, a shadow that shouldn't be there, that signal doesn't go to the thinking part of your brain first. It goes to the amygdala. The amygdala doesn't wait for confirmation. It doesn't check whether the shape in the dark is a person or a coat on a hook. It fires first, asks questions later, signaling your hypothalamus, which activates your adrenal glands, flooding your bloodstream with adrenaline. That adrenaline hits your heart directly, triggering the misfiring beats you feel as a skip. This all happens before your prefrontal cortex. The slower, rational part of your brain has even finished processing what you're looking at. You're feeling the physical reaction to a threat before you've consciously recognized it. Your heart isn't responding to your fear. It's responding to a decision your brain made without asking you. If you've ever felt like your body knew something was wrong before you did, this is why. Not intuition in some mystical sense. A hardwired shortcut, built to save time when time is the one thing you might not have. This is the exact mechanism a lot of people ask about when they message this channel confused about their own bodies. So if you've ever felt your reactions happen faster than your thoughts, drop a comment with what set it off, because a few of those stories are shaping an upcoming video. So the brain moves fast. But is this a human trait or something inherited from much further back? The response isn't human. It's ancient. This reflex wasn't invented for humans. It's something we inherited, almost unchanged, from creatures that came long before us. In the early 1900s, physiologist Walter Cannon at Harvard was the first to formally describe what he called the fight-or-flight response. But Cannon wasn't just studying humans. He was studying how this exact pattern shows up almost identically across the animal kingdom. Watch a deer the moment it hears a twig snap. Head up, muscles tense, heart rate spiking within a second before it even knows what made the sound. A mouse does the same, sensing an air pressure shift that might mean a hawk overhead. Their hearts don't wait for certainty. They react to possibility. That's the key detail researchers keep pointing to. This system was never built to be accurate. It was built to be fast. A deer that pauses to confirm the sound was really a predator doesn't get a second chance. Evolution rewards speed, even at the cost of 100 false alarms for every real threat. So that heart skip isn't a uniquely human quirk or a side effect of modern stress and caffeine. It's a reflex older than your species, older than mammals, older than the first creature that ever grew a heart with chambers. Every time your chest flutters, you're running software that predates humans by tens of millions of years. And if this reflex is that old, that automatic, and that indifferent to whether the threat is real, it raises an unsettling possibility. What if your body can't actually tell the difference between something genuinely dangerous and something that just looks like it is? The body doesn't know the difference between real and simulated danger. This is where it gets genuinely strange. Your body's alarm system doesn't just react to real threats, it reacts identically to threats it knows, on some level, aren't real at all. In a study that monitored visitors' heart rates as they walked through a professional haunted house, the results were almost unbelievable. Participants who knew they'd paid to be scared, who knew every jump scare was staged, still showed heart spikes nearly identical to genuine emergencies. Their rational brains understood the truth completely. Their amygdala didn't care. The same shows up with horror films. Viewers wired to heart monitors during jump scares show spikes of 20, sometimes 30 beats per minute in a fraction of a second, the exact premature beat pattern from Section 1, while sitting safely on a couch, fully aware they're watching a screen. The system doesn't check context. It only asks, movement, sound, shadow, could this be dangerous? If the answer might be yes, it fires regardless of what your conscious mind knows. It's the same reason a sudden loud noise makes you flinch, even when you caused it yourself, dropping a glass, slamming a door too hard. For one fraction of a second, before recognition catches up, your amygdala treats it exactly like a gunshot. There's no discount rate for probably fine, only fast or slow, and fast always wins. It's a strange kind of proof. The reflex is so ancient and automatic, it can be triggered on command. By strangers in masks, in a building you paid to enter. Your body isn't overreacting. It's doing exactly what it was built to do. Respond to the possibility of danger, not the certainty of it. Which raises something important. If this system fires so easily, why doesn't your heart just stay racing forever once it starts? The vagus nerve, your body's emergency brake. If adrenaline were the only force acting on your heart, every scare would send it spiraling into a racing beat that never came back down. It doesn't, because your body built a counterbalance directly into the system. And that counterbalance is the real reason the drop feeling exists at all. Running alongside your sympathetic nervous system, the one behind adrenaline, is the parasympathetic nervous system, or rest and digest. Its main highway is the vagus nerve, connecting your brainstem directly to your heart. While adrenaline speeds your heart up, the vagus nerve pulls it back down, braking almost as fast as the accelerator gets pressed. That brief pause after the early beat, the part that makes it feel like your heart stopped, is largely the vagus nerve doing its job, buying your heart a moment to refill before the next beat lands. Researchers studying vagal tone, how strongly and quickly this nerve responds, have found that people with higher vagal tone recover from fear responses noticeably faster than those with lower vagal tone. It's part of why some people shake off a scare in seconds, while others feel rattled for minutes. That flutter in your chest isn't one system malfunctioning. It's two systems arguing in real time. One shouting to run, one insisting it's safe to slow down. What you feel as a single strange skip is your own nervous system negotiating with itself, dozens of times a day, most of which you never notice. If you've ever wondered why some people seem unshakable under pressure, while others feel every jolt for minutes afterward, vagal tone is a big part of the answer, and it's something worth digging into properly in a future video. So if that's something you'd want explained in full, let us know in the comments, and it'll help decide what's next. So the mechanism is ancient, automatic, and self-correcting. But why hasn't evolution simply turned this reflex down, now that most of us aren't facing actual predators anymore? Here's the uncomfortable part. Evolution hasn't turned this reflex down because it hasn't had a reason to. The amygdala and adrenal system were built to react to physical predators, and physical predators are, for most people, essentially gone. But the alarm system doesn't know that. It's still fully online, still scanning, still ready to fire at the first sign of possible danger. The modern world is just full of things that trigger it without ever being an actual predator. A near miss on the highway, a phone buzzing at 2 a.m., a notification that makes your stomach drop before you've opened it. None of these are life-threatening. All of them trigger the same premature beat, adrenaline, vagus tug, of war from the last two sections. Your body has no separate, calmer response reserved for modern stress. It only has the one system, and it fires every time, whether the threat is a lion or a Slack message. It's part of why jump scares work so reliably, why doom-scrolling, unsettling news late at night leaves your heart pounding for no clear reason, and why panic attacks feel so physically real, with no danger nearby. The body is running its oldest program, one never designed to tell a genuine emergency from a stressful evening. Understanding this doesn't make the flutter disappear, but it reframes it. That skip isn't a sign something's wrong with you. It's a sign. A multi-million-year-old survival system is still fully functional, still doing its job with total commitment, even in a world that rarely asks it to save your life anymore. So the answer is simpler than it feels. Your heart never skips a beat. It adds one, pauses, and catches up a sequence triggered by a brain structure that reacts before you're consciously afraid, powered by a stress response inherited from animals that lived long before humans existed, and reined in by a nerve that's been negotiating with your fear response your whole life. It happens in haunted houses. It happens on movie night. It happens when a car swerves too close, or a shadow moves wrong, or a phone buzzes at the worst possible moment. Every time, for the exact same reason, a system built before language, before tools, before anything resembling a modern human, still running exactly as designed. So the next time your chest does that strange, sudden flutter, know what's actually happening underneath it. You're not malfunctioning. You're not broken. For one fraction of a second, some ancient, unthinking part of you is still standing in the dark, listening for something in the trees, and it's still, after all this time, trying to keep you alive.